Welcome to the last session of this conference with a title that promises to clear up everything that's happened in the past couple of days, if not the past 100 years. It's Armond Duwell from the University of Montana, and he's going to talk about understanding quantum mechanics, understanding quantum theory.
Thanks. First off, of course, thanks to the organizers of the conference. And by the organizers of the conference, I don't just mean the people that are listed on the program, but all of the other people that have made this happen, the people that are getting us food, shuttling us around, and all of those other wonderful things that are just essential for a conference. I'm quite pleased and honored to be invited to speak at this conference, which is in honor of Jeff's work and foundations of physics. I've known Jeff since I was a graduate student, and I have a lot of admiration for Jeff and the work that he's done. He's been very good to me in terms of fostering my career, and I appreciate that greatly. But one of the features that's a little bit humorous, the great irony of inviting me to speak at a conference in honor of Jeff is that Jeff and I have never agreed on anything. Which I think is mostly fair, right? We have very deeply different intuitions in a lot of cases. But I hope to make that different today, Jeff. I think I'm going to say something that at least we can agree on in part. Okay. With that, I'm going to get going. So the topic of the talk is understanding quantum theory, and what I'm going to do is try out some ideas which haven't been tried out before except in my own office, talking to myself and things like this. So I'm very much looking forward to constructive criticism. So first, let's just kind of start with the problem. So there's this question that people who've worked in foundational issues in physics have been very occupied with for a long time, and it's this one. What's the world like if the theory is true, right? And what we are doing by asking such a question is we're already presuming that we have certain kinds of representational resources that a theory provides, whatever they may be, but they're not somehow enough. We need to flesh those things out, right? And the reason why we want to flesh those things out is to do something like enable the explanatory power of the theory, which is otherwise lacking, right? The quick example here is something like the two-slit experiment, right? We've probably all had the experience where we remember seeing this thing for the first time and having it described. And even if we had the kind of bare-bones quantum mechanical representation of what was going on, we're still left wanting, right? We need more. And I take it, an interpretation is something that's supposed to provide that extra piece, right? And I think that's a very kind of standard view about what's going on. Now, how does explanation connect to understanding? Well, this is one view. I think it's arguably the kind of received view. It's called the simple view. That's not a pejorative term on my part. This is what the person, Strevens, who holds this view, calls it himself. We understand quantum phenomena when we grasp their actual explanation. Okay? An explanation, at least for Strevens, is given in a kind of very meaty ontological way. So think causal, think ontological. Okay? That's where explanation lives and understanding follows along. Now, the problem, of course, is that if this is your view of understanding, then when we ask questions like this, the kinds of questions that people in this room have been asking of quantum mechanics, like what assumptions signal out quantum correlations in the space of no signaling correlations, it's hard to connect this back to providing understanding. Why? Well, in part because it's not clear how that's explanatory, right? At least in the kind of explanatory way that Strevens has in mind, and indeed a lot of the people that have worked on foundational issues in quantum mechanics. Now, one of the nice things about Laura's talk, of course, is that she's shown us ways in which we can broaden our conception of explanation. And of course, if we broaden our conception of explanation, then we can get more understanding back in the picture, even if we were to stick with the simple view of understanding. And that's certainly a fruitful approach. That's not the approach that I'm going to take here. Yeah, this goes without question. No understanding without explanation if we take the simple view. What I'm going to do is I want to loosen up our conception of scientific understanding, or understanding generally, really, and really kind of decouple it from explanation. And I'm not hostile to explanation or anything like that. It's just that that's the kind of piece that I want to move around. So the aim of the talk is this, to provide a notion of understanding which really makes sense of at least some of the epistemic value of recent work in foundations of quantum theory, especially of the kind that people in this room partake in. Okay? So that's the setup. Here are the sections. In the second section, I guess, what I want to do is articulate a notion of understanding, which is called modal understanding. This conception of understanding is largely due to Bihan, and I'm going to provide a version of that kind of conception of understanding. Then I'm going to talk about modal understanding and some of the work that's been done. For those of you who know Rob Speckin's book with Kira Bella, I borrowed the title from you shamelessly, but there's your credit, okay? I think it's an excellent and beautiful book, and I highly recommend it. And then I'll just wrap things up. So let's proceed. What is this new notion of understanding that I think is actually going to give us some payoff? So here's the basic story. Modal understanding involves this. We say that one has some modal understanding of phenomenon P, or phenomena P, if and only if one knows how to navigate some of the possibility space associated with P, associated with the phenomena. Now I need to tell you what that means, right? So I need to tell you about the pieces. First, regarding the possibility space. And this is, I'm just going to say, an area where the formulation becomes very different than the previous formulation that Bihan had given. What's a possibility space for phenomena? Well, it's going to be the set of representations of those phenomena, or any subsets of the phenomena, and the relations between them. I'm using space here in a kind of loosey-goosey way. Don't take too much into it in terms of conditions that you would put on how to represent such possibilities, et cetera, et cetera. It's just to kind of give you a notion. I'm interested in this class of things and the relations between them. What's in this space? Representations. And representations are, a dime a dozen, or perhaps a dozen. Just about anything can represent anything else, or at least that's the kind of view that I take of representation. So it can include the usual stuff, mathematical models, but it doesn't need to be limited to that. It could be diagrams, simulations, toy models, and all sorts of other things. Okay? One thing I want to recognize, and I think this is important, is that, of course, not every representation is going to be interesting for certain kinds of purposes. So there's going to be some adequacy conditions associated with the kinds of representations that we want to entertain. Now, I'm not going to give you any particular adequacy conditions for these things. I mean, in many ways, that would be to solve the demarcation problem. But you have a sense of the kinds of restrictions that you want. You want naturalistic representations. You want representations that meet certain kind of quantitative demands, so on and so forth. But I want to leave that open, and I think it's important to leave open because I think it's an area which can be very much in play. Standards can shift, not only from scientific field to scientific field, but even amongst practitioners, and that's something important to recognize. And I'll try to draw that out a little bit as we go. Now, what about navigating a possibility space? What's this notion? Well, it's constituted by three parts, three kinds of things. One knows something about how to navigate a possibility space for the phenomena. If and only if one knows how some representations represent some subsets of P. Okay? And know how is an operative word here. It's distinguished from knowing that. So just being handed a representation, or somebody which, for example, has a quantum mechanical representation of the two-slit experiment, doesn't mean you have any understanding of it. You need to know how that thing that a person has given you actually hooks up to the world or hooks up to the phenomena in an interesting way. And that know-how is constitutive of understanding. Additionally, with respect to these representations, you need to know how they relate to one another, okay? And sometimes the relationships can be quite systematic, other times they won't be. But knowing how they relate is, again, constitutive of understanding. And then finally, one needs to know how the phenomena might restrict the boundaries of a probability space. And here the thing that I have in mind, and what Bihan had in mind as well, is something like Bell's theorem, okay? Given that the phenomena are what they are, there's only certain kinds of representations that are going to be possible, and others are excluded. Now, my intuition here, and I don't know if you share that, but that this is really important. But it's not really important because it provides any sort of explanation of phenomena whatsoever. But I think it provides us with a certain kind of understanding. What kind of understanding? Modal understanding. We learn about the space of possible representations that are adequate for the phenomena.
All right. For a typo, should that be probability space?
What?
Should that last possibility, should that be probability?
No.
Or did you misspeak when you said probability?
Oh, I could have misspoken, but no, no, possibility space. All right, now, I've talked about modal understanding of phenomena. There's a corresponding notion of modal understanding of a theory, and they're very much related to one another, but I think this is a very natural thing to do. One of the things that happens in these discussions is there's a very easy slip between understanding the theory and understanding the phenomena. And I think one of the advantages of this way of cashing out the view is you can easily see why people make that slip. So modal understanding of a theory. One has modal understanding of a theory T if and only if one knows how to navigate some of the possibility space for T. What's that? Well, it's just going to be the set of representations associated with T and the relations between them. One knows something about how to navigate the possibility space for a theory if and only if one knows how some representations of T actually go about representing. One knows how those representations relate. And then finally, one knows how the theory itself restricts the boundaries of this possibility space. And of course, the thing I have in mind here are things like axiomatizations of a theory. Those are the kinds of things which restrict the boundaries of the possible representations that can be given using a particular theory. All right, now I want to just quickly gesture to some relations between these two notions of understanding. So there's some entailment relations, but there are different cases. So let's suppose that you have complete modal understanding of a theory. And then suppose that T is at least partially adequate to some set of phenomenon. So in this case, you can take your theory to be classical mechanics or something like this. And you can take P to be the set of quantum phenomena. And lo and behold, of course, as we know, there are some classical models that do perfectly fine describing quantum phenomena. Not all, of course, but some of them. So complete understanding of classical mechanics means that you're going to understand some of the relations that are also included in the class of those that are in the possibility space associated with the phenomena. Now, you can have other cases. So suppose the theory that you have complete modal understanding of is completely adequate for some set of phenomena. So let's take T to be Bohm's theory, and the P is the quantum possibility space. So if you have complete understanding of that theory, that means you're going to have partial understanding of the possibility space associated with quantum phenomena. What kinds of things are ruled out? Well, Everettian theory, okay, or GRW theory. All of these things are also in the possibility space associated with quantum phenomena. Now, what about the other direction? This is very similar. Suppose you have complete modal understanding of the phenomena, and suppose that you have a theory which is partially adequate for that. Stick with the exact same examples here. Your theory is classical mechanics, the phenomena are quantum. If you have complete modal understanding of quantum phenomena, of course, part of that space is going to overlap with the possibility space of the theory. And similarly, if you have complete modal understanding of the phenomena, well, in this case, if you have a theory that's adequate to the phenomena, you're also going to have complete modal understanding of the theory itself. So if you understand the possibility space associated with quantum phenomena, then of course you're going to have complete modal understanding of Bohm's theory, for example. Okay? So hopefully this gives you a sense of what I have in mind. Next, I just want to address some obvious questions. Are the notions that I just developed actually understanding, or are they something else? And this kind of slide is the if it walks like a duck and talks like a duck, then it is a duck kind of slide. So if it does the things that understanding does, then I'm going to say you ought to just grant that this is a species of understanding. So first off, understanding is a cognitive achievement. I don't even think this one bears discussion. It's quite obvious that understanding, in the way I've described it, is a cognitive achievement. Involves something like grasping connections. That's certainly true in all the different modes of understanding. So you need to be able to grasp how a representation relates to the phenomena it purportedly represents. That's one grasping. You also need to grasp the relationship between different representations. And then also you need to grasp how the phenomena might restrict the boundaries of the possibility space, or in the case of modal understanding of a theory, you need to grasp how the theory itself restricts its possible representations. Now, the next one's kind of loaded, and I won't give a very detailed defense here. Understanding is thought to manifest itself through a number of abilities, including abilities to infer, generalize, transfer, answer what if things would be different questions. And I think all of these things are true for a person who has modal understanding, either of a theory or of the phenomenon. The ability to make inferences, if you have understanding, is pretty transparent. If you know how a representation represents, you're able to make inferences from your representation to the target of the representation, for example. Ability to generalize. Well, look, if you have one representation which adequately fits certain aspects of a phenomenon, and you know how the representations are related, you might know what other representations would be adequate to that phenomenon, so on and so forth. And it goes on. And then finally, it's not readily transmissible. Understanding is something that you have to work hard for, okay? It's not as easy as factual knowledge. So, for example, there's a big difference between being able to state Bell's theorem and to grasp how, given the way that the phenomena are, it puts constraints on the set of possible representations of that phenomenon. And that's the kind of distinction that I want to get at for 4, is not readily transmissible. It's actually pretty easy to get somebody to memorize what Bell's theorem actually states. It's very hard, or more difficult at least, to get them to grasp those kinds of connections. So that's the sense in which it's not readily transmissible. All right, so is it a notion of understanding? Yes, I think it is, and these are some of the reasons why. But of course, there are other objections. You can say, Duwell, you're crazy. This is just a trivial view. Understanding is ubiquitous and everywhere, and isn't that a bad thing? So, for example, if you're super permissible about what a representation is, well, then just about anything can provide you with some kind of modal understanding. And isn't that just a real problem? And I think there are 2 ways to address this question. One are adequacy conditions, okay? Certain kinds of representations people are going to find interesting, or more interesting than others, and that's fine. And that's going to cut down on the kind of class of representations that you consider. But then the other thing I would say is that understanding comes in degrees, okay? Certain kinds of mastery are not going to afford you much modal understanding. You know, if you've got a toy model of something, that's not going to afford you the kind of understanding that a full-blown theory is capable of. Why? Because its class of representations are limited, so on and so forth. So I don't think the view is trivial. I think it's actually quite substantial. But I understand those worries, and the thing to say is adequacy conditions and understanding comes in degrees, and sometimes very tiny degrees, as the case may be. The other consequence of the view is that false theories can afford understanding. And that might be worrying to somebody. It's certainly worrying to anybody which has the view that in order, you know, to gain any sort of understanding, it has to come from some truthy kind of beast, right? So if you've got the simple view of explanation, of course, you're going to say, well, only true explanations are going to afford understanding. And I think that's the wrong thing to say for a lot of reasons. So here's the kind of example in my mind. And this is the kind of thing that actually happened at the conference, which I was really happy about. So let's take two interpretations of quantum mechanics, or competitor theories, whatever you want to call them. Take Bohm's theory and like an Everettian interpretation, right? At most, one of those things can be true. Probably most in the room think neither are true, at least not Bohm's theory, maybe something else, but anyway, that's not what's important. But one of the things which I thought was really interesting, and this came up in discussion of this example that Matt had in his talk, I think Lucian said it, how does this work in Bohm's theory? It was a really fruitful mental tool to be able to figure out what was going on here. What alternative representations of this kind of thing are possible? And then, of course, the value of that is you can compare what's going on in, for example, a straightforward Everettian analysis as opposed to a Bohmian one. And then if you want to say something about the world that's in any way kind of definite, you're going to say something like, is there anything in common between these representations, these very different representations? And maybe that's the kind of kernel of truth that I want to extract from a situation. So I think false theories can be highly conducive to understanding, which is a view that I think is very hard to maintain if you take the simple view of understanding. And the other distinction to make is quite deliberately the target of understanding is the way the world appears to us rather than the way the world actually is. Which isn't to say that this view is hostile to those who only think that the appropriate target of understanding is understanding the world with a capital W, or noumena with a capital N, or M, as Gilles wrote earlier today. So that's the target. I think we get understanding of the phenomena, not necessarily of the actual world, although that's certainly commensurate with the view. I think we get understanding in a lot of other occasions as well. All right. Now, that's the view. Hopefully I've made it sound not completely nutty, or maybe nutty, but maybe a tiny bit plausible as well. Now what I want to do is try to deploy the view to capture a lot of the different activities that people are up to who work in this field. So, like I said before, I'm borrowing the title from the Speckens and Curabella book that recently came out. And in this book, Speckens and Curabella wrote a really nice introduction. They recognized that work in information-theoretic circles, foundational work in information-theoretic circles, is a kind of motley collection. And I think they did a really nice job of providing certain kinds of commonalities that are present in a lot of these different things. So I'm just going to take that framework over and then apply modal understanding to each one of those kinds of categories and see what we come up with. So the first thing they mention is that a lot of the approaches in quantum information theory are associated with a more pragmatic perspective. What that means is that instead of taking the kind of, what I would say, natural approach if you're a philosopher, which would be to like say, here's the fundamental stuff in the world, here are the laws in which these fundamental things interact, and here are the appearances that you get as a result of it. Instead of describing the world like that, we describe the world in terms of what we can or can't do, or what we can or can't know. And then, of course, things that we've seen are quantum foundations in the light of quantum information. So there are obviously a whole new host of phenomena that have been discovered over the last 20 years or so, which are valuable conceptual resources. But of course, there have also been very valuable kind of formal techniques which have been developed in this area, and we ought to use those to understand quantum theory. Then, of course, there's a shift from interpretations of quantum theory to reconstructions. No need to describe that any further. The move to operational frameworks, as we've seen on many occasions here today, as well as yesterday. Again, think about things in very direct, non-ontologically committal ways. And then the use of foil theories to compare and contrast with quantum mechanics. So let's take a look at each of these different areas and ask the question, how do these kinds of moves facilitate understanding when understanding is understood in my preferred way, the modal way? So this is the kind of question that you're going to ask in quantum information theory. What does quantum theory tell us about what we can learn or do with the quantum world? One of the things that's obvious about this question is it's an impetus to utilize the predictive power of quantum mechanics, as I've discussed, and as we all know, there are some really amazing and terrific new phenomena that we have as conceptual resources for considering. And of course, when we discover those new kinds of representations in theory, we discover something about the possibility space associated with it. And the other thing that I think is maybe playing a role here is that it facilitates understanding because it's in terms of things that we know, that we have contact with, in terms of stuff we're intimately familiar with. And that could be conducive to understanding. What about quantum foundations in the light of quantum information? Well, again, in the Speckens and Kirabella book, they listed a set of questions which are typical for this area of research. So let's just go through them one by one and see what they do. Well, which principles of quantum information theory can account for its information processing advantages? Well, I think this question could be reformulated in a way that is more conducive to seeing how it obviously promotes understanding. It can be reformulated as the question, how are all quantum mechanical models that exhibit information processing advantages related? To give a quick example here, you might be interested in quantum speedup. And if you are, you should read Mike Cafaro's work, who's shown that all instances of quantum speedup involve a particular use of entanglement. And that, I think, is promoting understanding. Does the possibility of achieving one kind of information processing advantage imply the possibility of achieving others? I think this is another way of asking this question, or perhaps that question is in this kind of category. How are quantum mechanical models that exhibit information processing advantages related to others that do so? And of course, knowing about the relations between representations is constitutive of understanding. Is quantum theory the only theory where these advantages arise? Here it's kind of more interesting in a way. You could reparse this as, are there non-quantum models that can represent the phenomena and meet tacit adequacy conditions, whatever those are? What is the possibility space associated with quantum phenomena? Okay? And of course, the richer our knowledge of that structure, the more understanding we can gain from it. From interpretation to reconstruction. Why the quantum? So one of the ways that you might think about answering this question, or just asking yourselves, how are all quantum mechanical models related? And in giving an answer to that question, you might be addressing the other one as well. But saying how they're related is, again, constitutive of understanding. The other thing that I think is important here and is going on, which has been mentioned as well, is there's a question about which axiomatization best facilitates our understanding. And if you read Chris Fuchs' article in the Speckens and Curabella book, I think Fuchs makes a really big deal of that. He recognizes that there have been, good re-axiomatizations of quantum theory, but his beef with them is that they're not right, and of course he has a bit of a difficult time saying why he doesn't think they're right. But I think he might enlist the use of modal understanding and suggest that the reason why he's not happy with these axioms is that he doesn't think they're going to facilitate understanding. And he's searching for those that will. And of course, those that best facilitate understanding, right, that's the million-dollar question. I don't know which ones they are, but that's one reason. You might have your suspicions or prejudices about what you think is going to be more conducive to understanding. All right, operational frameworks. Frameworks as restrictions, transitions, etc., all have operational significance. One of the obvious important things here is that you go to a kind of ontologically deflationary view, and that has certain kinds of epistemic advantages. I'm not sure that in itself has advantages for understanding. We're taking less risky epistemological moves there, and that's always valuable. But what I would like to suggest is that perhaps this operational framework facilitates our understanding, again, insofar as it relates it to us and things we intimately know about, how to engage the world, how it affects us, so on and so forth. Also, what's nice about these operational frameworks is that they're a very good research tool for investigating the boundaries of the possibility space associated with certain kinds of phenomena. Of course, this is one of the things that Jeff's book brings out so nicely. What can FOIL theories do? Well, one of the things that Speckens and Curabella point out is that they can demonstrate the independence of axioms. And that can be a really nice thing to do. Tentatively, I want to float the idea that having independent axioms facilitates our understanding. It's easier to grasp how things are related when we relate them via independent axioms rather than somehow overlapping ones. And of course, again, you can ask this question, which axiomatization best facilitates understanding? You also look to demonstrate what is distinctive about quantum theory. Yes, I think that's right, and this is a comparative notion. You might ask yourself, what is it that all and only quantum representations have in common in the possibility space for P? What is it that distinguishes those particular representations from other ones which are adequate? Things we've seen at Bananarama. Okay, so this is the particular thing that Jeff has shown us, which is the crux of the book in some sense, right? One of the things, or a couple things I want to point out is that we're entertaining, one, a limited set of phenomena, as has been pointed out, but also a kind of counterfactual possibility space. We're not looking at what the actual phenomena are, we're looking at a large space of possibilities here. And this is really fruitful, because we can do what with it? Well, I think we can identify the boundaries of the quantum possibility space by looking at it from this bigger point of view. And of course, that's constitutive of modal understanding. All right, what did Rob do this weekend? Well, quite a bit, but here's one way of thinking about what he's doing, is that Rob is interested in, and others, by the way, interested in exploring the quantum possibility space in light of a certain adequacy condition, namely, wants to look for causal representations that don't violate Leibniz's principle and allow for standard kinds of inferential moves. Okay? My guess is that one of the motivations that he's using here is that he thinks that's going to promote the most understanding. Okay? Alternatively, what we saw Broussard doing here was entertaining an alternative adequacy condition. And this one was that perhaps local realistic representations that recover quantum phenomena are going to be the most conducive to understanding. So one of the ways to think about adequacy conditions is that their individual researchers or group of researchers' best bet as to what's going to promote the most understanding. All right, let me just wrap things up for you. We know the problem. If you take the kind of standard view of explanation, which is heavy with causal and perhaps ontological notions, and you couple that with the simple view of understanding, a lot of the great work that we've seen people do in quantum foundations just doesn't turn out to promote understanding. And that's weird, right? There are certain kinds of plausibility tests that any philosophical notion needs to pass, largely that it is more or less descriptively correct. And I think we're failing in that endeavor. So I chose to work with a new notion of understanding. Modal understanding of phenomena is one of the particular notions that I articulated, but there's a closely corresponding one, and that's modal understanding of a theory as well. And it's all about exploring possibility space in terms of how things represent, how things relate, and what the boundaries of those spaces are. Now, we've seen all of these different kinds of activities. By the way, as you've obviously recognized, they're not mutually exclusive. But I think of all of these categories, no matter how you parse them, they all, in some way or another, seem to facilitate modal understanding. And that was kind of the goal. So I look very much forward to seeing what you guys think. Thank you.
Question?
Two-part question. You used the word representation many times on most of your slides. Would you be happy substituting a word which is not so representational, like model? I tend to think that what's distinctive of quantum theory is that its models don't represent the world directly, but they're still used. So the question then becomes not the question how do the models of this theory represent, but how are they used? Is that an okay substitution within your framework, or is that jumping out?
So here's why I like representation.
Yeah.
It's because it's massively inclusive. I think we represent the world in many, many different kinds of ways. And we can also take different attitudes within the same theory about what's representational. For example, you don't think the quantum state is representational, but I take it that some part of the framework you view as representational. And you might want to be very careful about what kind of ontological commitments you make, but I take it you still think what you're doing is representational in a certain kind of way.
I think when we're using quantum models, we are representing.
Sorry?
When we are using quantum models, we are representing.
Yeah.
The models themselves do not represent.
Oh yeah. So if that was the question, then I'm with you completely. I don't think there's any kind of intrinsic representational relationship that exists among different kinds of things. I think it's a three-part relation: thing, target,
that's
and
not
me.
quite enough. I mean, we are using the models to make representational claims, but we are not using the models to represent.
I think we use models to represent all the time.
We don't use quantum models. I mean, there are no beables in a quantum model, therefore nothing in a quantum model directly represents.
Okay, so that, I mean, we differ in that regard. I mean, I don't think that beables are the only vehicles for representation.
Okay.
Again, I'm extremely permissive in terms of
Okay,
representation.
Let's drop that line.
Yeah.
If you're going to be permissive about explanation, more permissive than the paradigm theorist of explanation, like Strevens, then couldn't you still say that the kind of modal understanding that you're after, which I think is really good, is a demand for explanation of a more permissive kind?
So I am generally in favor of opening up the doors to explanation. But I also don't quite know what to make of it right now. I think it's in flux. I agree with Laura that I think we're moving beyond the causal models, and we've certainly done that in many cases. But I'm not quite sure that we've settled on exactly what else is required. Some kind of asymmetry is still key, but we're going beyond causal. Maybe you want to cash that out in terms of counterfactuals. I'm not really sure. But I tell you, one of the things that I've thought about is that instead of thinking about understanding as what happens in a special case of explanation, it might be more fruitful to think about explanation in terms of a special case of understanding. I haven't developed that at all, but my suspicion is that that might actually shed some light on weird stuff about explanation. So to give you a kind of a sense of where that's going, right? At least in the 80s and early 90s, there was kind of two very different views of explanation. One's unificatory, the other is causal. And both seem to capture important stuff, but then putting them together seemed kind of impossible. I'm wondering if understanding isn't the means to bridging that gap. Unifications promote understanding, okay? And instead of perhaps reserving the word explanation for unifications, that's best left to thinking about it promoting understanding instead of explanation. So that's a sense of where I think this might be useful. But I don't have any kind of concrete views that explanation has to look like this or that, but so I'm open.
Thank you.
Yeah, thank you.
Michael.
My question was actually addressed just now, so.
Okay.
Lucas?
Yeah, thanks. This was really interesting. One thing you said that I'm hoping maybe you could say a little bit more about was you started by using the language of know-how when you were talking about how representations represent their targets.
Yeah.
And then you moved on to saying something about grasping. Like, I'm wondering if you can say a little bit more about what you mean to understand how a model represents its target system.
So I buy into there being a legitimate distinction between knowing that and knowing how, which does not mean that I think that they're mutually exclusive. I think they oftentimes go hand in hand. One of the ways that people have talked about know-how is in terms of grasping. It's that something else that's going on besides mere propositional knowledge. So the standard example in the literature is about knowing how to ride a bike. You can memorize all the propositions that are required that describe good bike riding and still not know how to do it because you don't grasp how to put those things together in the right kind of way to interact with the world. But let me just say that this is taking me out of my comfort zone into more general epistemological waters, and I don't have strong views in that area. So I'm not sure that I did much to answer your question, except give you a sense that when shifting between grasping and know-how, that these are different kinds of descriptions of the same kind of epistemological event.
If I can just follow up, yeah, I guess I'm wondering if there's anything in general you can say about, you're talking about representations representing a system. This seems to be playing an important role in knowing what you're dealing with in this, possibility space of representations. I'm wondering if there's anything in general that can be said about being able to identify when that's done successfully or something like that.
Well, you mean like tests?
Well, I don't know. I mean,
Because
do you have any?
in a sense there are tests, right? And this was the if it walks like a duck and talks like a duck slide. Right? So you're going to understand if you can do this kind of thing. It's a test, as it were, for these kinds of abilities. Yeah.
Bill?
This is I mean, learning a bicycle is sort of an obvious thing but there are all sorts of, I mean, I can remember when I was a grad student, I happened to be the TA in a logic course that the other ones had to take, because I was the only one that passed it, certainly. And but learning, like understanding logical inference
you know, if you got one of the things that you'd find a problem proving something, like especially things that involve existential instantiation, where they're all this different. And I found that what really mattered was if I could get students to work through, you know, a specific example, but really work through it, then they could do all these other examples. But if they didn't do the details themselves,
That's transfer.
then you just never got it. And I think this is typical of all kinds of things in math and stuff. And so it's not just bicycle riding.
Sure, absolutely. Well, I agree completely, obviously.
James.
Well, this is just, I don't know how relevant it is, but related to what Lucas was saying, there are a number of different things one might mean by I know how to do something other than I know how to perform a particular task. And I don't think that you need to draw the distinction between this kind of know-how with respect to propositional knowledge that it sounded like we were drawing, right? So to know how a certain theoretical structure works, I'm reasons responsive, I can defend it against various threats, I know other things, right? But I may cash that all out propositionally in the case of my use of theory. It need to be that I have this thing that transcends propositional knowledge in the way that bicycle riding.
Like I said before, I don't take a stand on whether know-how is reducible to propositional knowledge or not. What I want to say is that even if it is, it's a kind of useful distinction to make nonetheless.
I was agreeing with that, but I was saying that even if it isn't,
Uh-huh.
there's another thing that you want, which is knowing how to deploy the theory is different from knowing that the theory applies, right?
Sure, absolutely. Yes, yes, absolutely.
Now I have a sort of a factual worry. Can
Yeah.
you go back to your second Venn diagram?
This one?
No, the third. So maybe I just I'm not familiar with your theory enough just yet, but some of these difficulties made me a little worried because to have a partial modal understanding of or maybe it was the first one. To have a partial modal understanding of
This one?
classical mechanics, complete modal understanding of classical mechanics. Does that give you a partial modal understanding? Because what I don't know is how the phenomena or I'm not forgetting your axiom, but I don't know how it's constraining that space at all in any way.
That's right. So certain elements of understanding, understanding kind of varied along 3 dimensions, right? One was how the models of the theory actually represented the world. That's one dimension. Another dimension is how those relate, and those are pretty independent, actually. And then the final one.
Those weren't conjunctive, they were disjunctive?
That's right. So modal understanding can vary in multiple dimensions. Yeah, okay, good.
I really like, the number of features of the models, especially the knowing how and the fact that the false theory can explain.
No, it provides understanding. I didn't.
Understanding, sorry.
It's easy to slip, right?
I would say that they can explain because I think that then there would be too much of a gap between understanding and explanation. But one thing about knowing how as explanation, I think it's pretty clear that knowing how cannot be reduced to knowing that, although knowing how many times go with knowing that. And I think given Wittgenstein, given a lot of the new history of science, it's pretty clear that the knowing that is too narrow to give a lot of understanding and explanation, especially if you want degrees of understanding and explanation. One thing that I want to ask, or maybe to suggest, you talked about degrees of understanding. Maybe it could be also degree of explanation. But then you gave only general standards for understanding, that could be, even if someone just know how to produce, for instance, all the possibilities of a theory, without, for instance, knowing the few principles that can produce that. So I wonder whether one can add to such an account some standards that would rank, explanation, or some ways, or that would allow us to evaluate. One explanation is deeper, or one understanding is deeper than another.
So, I think it's going to be quite hard to quantify these things. I've suggested that there are these kinds of qualitative variations. And I think, as are such, there might be some clear cases, but I don't know that, for example, it's going to give you much purchase in deciding, for example, what the better interpretation of quantum mechanics is, or something like that. I think we'd get into the usual, well, this has this feature which is virtuous, but then it has this drawback. Well, okay, I've got different virtues and different drawbacks over here. I don't think this is going to help with that sort of thing. What it is going to do is explain how both of these different ones can promote understanding. And I think that's really important.
Yeah, I didn't think that they would be like, quantitative, but there is the intuition, that if you can explain how to produce all the possibilities by two principles, your understanding is deeper than if you can just produce all the possibility, but you cannot see these principles. Mm-hmm. And related to the unification, if you can show that you can unify these possibilities with another theory possibility, then you explain, or you understand better. So it's more like, adding to the minimal. I understand that you want to be
So I don't think I need to change anything to capture your intuition, and it's number 2, and possibly 3 as well. In one case, you've got all the representations associated with the theory, but then you know how they relate, perhaps in virtue of the axioms, or you understand how the axioms bound the space. Both of those are independent dimensions of modal understanding. So you're definitely better off if you've got exactly what you think adds to our understanding. I agree.
But
That's
don't
right
you
here.
think that if I just know, how to relate all the quantum states to other quantum states, but I actually, I do quantum information, but I'm not aware of the main principle of quantum information. So according to this, I have an understanding, but the intuition is that if I can summarize my understanding, by few principles, simple principles, then
Yes.
my understanding is better than.
Yes.
So you think that this capture these differences?
So it's the number of principles that I see.
Yeah, for instance, if I
Okay.
have just 2 principles
Now I got
that,
you. Yeah.
that allow me
Right.
to relate everything,
Right.
it's better
Sure.
than just having.
Sure. So the way that I would want to capture that intuition is just suggest that, yes, having a small number of principles can actually, in certain cases, facilitate understanding more than in other cases where you have a large number of principles. Although I don't think that we want to a priori say that that's always going to be the case, that sometimes having fewer principles actually makes things more difficult than if you have more principles. That's going to be the kind of judgment that I think needs to be made on a case-by-case basis. We all love the example of the special theory of relativity, but it's an isolated one. And it's not always clear to me that the fewer principles you have, the easier it is for you to grasp the relations among things. So, here's an example off the top of my head, right? So, we've got this standard way of doing logic, right? And we have the introduction and elimination rules, and usually we include a redundant rule. We usually talk about the introduction and elimination rule for the material conditional, which strictly speaking we don't need because it's logically equivalent to disjunctive negations where, But we actually think that this is a very valuable way to characterize logical inference, as if we had this material conditional, even though we don't really need it. So that might be a case where fewer principles might not facilitate understanding better. So I don't think there's anything I can say a priori about that. Yeah.
Michael? Is that?
Short question, I guess. So you want to focus on understanding and you want to distinguish it from explanation. And that's fair. Well, it's obviously fair. I'm just wondering, so you can think about understanding. You can think about understanding separately from explanation. You can think about explanation separately from understanding. Do you actually think that they can exist separately, or do you think that they'll always in general go hand in hand? Can you have one without the other?
Look, insofar as I'm not sure what explanation is, I just have no idea. If you have any of the kind of causally ontic-y restrictions, and you demand the truth be a big part of the game here, then I'm happy to say explanation and understanding can part ways. And the Bohm-Everetting kind of contrast is important here. I think Bohm's theory, even though I think it's false, does actually promote my understanding of quantum phenomena.
Rob?
Yeah, so I have some comments that are sort of in support of the notion of modal understanding. There's parts of it that I like. And I have some other comments which I think are elements of that definition that I don't like, but maybe because I don't understand the definition, you'll agree with me that it's part of the definition. But it's sort of my understanding of what you said. So I like the idea that we should understand understanding as navigating a space of possibilities. But the example you gave, so the possibilities would be particular representations of the quantum formalism with Bohm and Everett and others being examples. That strikes me as, if you're good at navigating that space of possibilities, then yes, that helps you understand quantum theory. And I think, the example of Lucian's suggestion, let's think of Wigner and Bohm is a nice example of that. And people who are good at navigating those possibilities do have an edge. But it doesn't strike me as definitional of understanding. So to my mind, the more important sorts of sets of possibilities that you ought to be able to navigate, if you want to say you really understand things, would be the space of different physical phenomena that are exhibited by quantum theory. So for example, if I have a particular interpretation which helps me make sense of more phenomena than some other interpretation, right? This interpretation is very good at making sense of these couple of things, but not so good at all this other stuff, then I understand it better. And the other possibility space would be like the possibility space of actual theory. So there's quantum mechanics and the foil theory part of it. And if I know how to navigate around that space and know how things are connected and what's the relation between these, I also have a better understanding of quantum theory.
Yeah.
And to my mind, like both of these sort of navigational notions are kind of present in among the community of people who works in this area. So for example, I would say a lot of people who work on the axiomatization don't think of the problem as, let's come up with the best axiomatization, one of us will win, but rather, we have all these different axiom schemes, and when we understand how all these different axiom schemes are related to one another, and how sort of they sort of fit together in a puzzle ball, like you can break it down to these ones, or these ones, or these ones, and now we understand how it all fits together, then we will understand what's going on. And so it's more a kind of interrelation between all these axiom schemes that's sort of constitutive of understanding. And similarly with, I would say, the landscape of foil theories, that the broader the set, the better. So just like the more physical phenomena you can link together, the broader the landscape of foil theories within which you can situate quantum theory, the better. So as Jeff mentioned in his talk, if you start with C-star algebras and it contains classical mechanics, quantum mechanics, and some super selective versions in between, and you derive quantum theory, you learn less than if you start with a broader framework. It's a lot of the activity has been, let's go to broader and broader frameworks that could describe more and more theories. Let's understand how these different frameworks are connected to one another. Let's try to pick out quantum theory within those. So all these things sound very much like navigating, but it sounded to me like this set of possibilities that you were referring to were kind of specific representations of a given theory or specific representations of a given phenomena. And so I'm just wondering, is there room for what I said, like take the relation between all the phenomena and all the theories?
I think there is, and I hope to state that in a better way. The most simple thing to say is obviously the more of P you can capture, the better. Obviously, so it does vary along that dimension too. So the bigger your class of phenomena that you can capture, the more understanding that this theory affords. So if you've got a class of phenomena that you want to capture, all other things being equal, the theory which captures a greater patch of that is going to afford more understanding. So it does vary along that dimension. Now, with respect to how the various axiom systems relate to one another, so on and so forth, so I guess the question is, in part, whether you can characterize the relationship between those two systems via their representations or not. So the way I've been thinking about axiom systems here are that they very much capture the boundaries of certain kinds of possible representations, and also they tell you kind of features that all models share. So suppose you add an equivalent axiom system on top of that. Well, it's not going to change the boundaries of the space, but what it does do is it's going to enrich your understanding of the relations among the representations. And I think that's a dimension of modal understanding. So, yay, right? What do you think?
I'm not sure I agree with what you just said, because I'm not sure what you meant exactly by representations in this context. To some extent, my comment was that it sounded to me like representations should be thought of as like Bohm, Everett, epistemic, whatever. And I was hoping that I could push you to have a broader notion of representation.
I am very permissive about what constitutes a representation. So no, I do not think you need an interpretation to call something representation. That's not part of the view at all. I used it to illustrate some of the points, but my notion of representation isn't wedded to anything like the standard, the old way of doing foundations at all. If you have certain kinds of adequacy conditions, maybe the only way to achieve those adequacy conditions is to go the interpretive route. But if you have other adequacy conditions, then it seems to me that your representations just don't need to meet those standards. You don't need all this extra ontological baggage in order to ask these questions, right? You might be interested in the relations among different theories or even different axiomatizations of theories, not insofar as, like, let's compare their ontological baggage, but you can compare other kinds of properties, which are more aptly mathematically described and don't have the baggage that the other interpretations have. So for me, we don't need to talk about interpretations at all to gain serious understanding about a theory.
Well, then maybe the one other way in which I want to push you is to allow that this talk of representations makes it sound like you're looking at navigating a set of representations of some phenomena or representations of some theory, which is sort of things that are all pinned to that theory, whereas often you can think of understanding in terms of navigating the phenomena and its brethren, it's the other phenomena that theory allows, or a theory and its foil counterparts, which is not about representations of that thing, but alternatives to that thing.
So, good. Maybe I can bring this part out more. And this is, again, why adequacy conditions are important. So let's take your toy model, right? So one of the things that, or many of those features of the toy model is that from a certain qualitative point of view, qualitative description of the phenomena, that toy model exhibits all sorts of properties that the quantum mechanical models do as well, right? And that's amazing, right? That was such a wonderful thing to learn, that there are other possible theories which have all of these weird things going on, which means that if you want to single out what is the unique feature of quantum mechanics, you're not going to do it by just pointing to those usual suspects. And then you can explore the class of possibilities there. So look, sometimes the phenomena that you're interested in, sometimes your P space, might be the phenomena described with respect to certain conditions of adequacy, and they might change. And when you change those conditions of adequacy, then of course you change the class of representations that you're interested in comparing. So I think in many senses, you reduce the quantitative restrictions on the adequacy of your representations. You get an enlarged space of possibilities for those descriptions. And I'm interested in all of the different representations there and how they relate. So I'm hoping that does capture a lot of the work that people do with FOIL theories, and also illustrate the role that having this play in the kind of adequacy conditions that we have for the descriptions of phenomena, for the representations of phenomena, that's also brought out as being a really kind of important parameter that recent foundational work has found useful to vary.
Great. So this is very similar to Rob's question, although perhaps put more crudely. It wasn't clear to me how to think of the kind of understanding that we sometimes get by understanding how things relate to one another in your picture. So if I say part of understanding general relativity is understanding how you recover Newtonian gravity in an appropriate limit, is that something that comes with navigating the space of general relativity of the theory, or is it something that's an interrelation between theories? So if you think of theories and their relations among each other, is that part of the picture? It doesn't seem like it, well, the way you formulate it doesn't seem like it is, but it doesn't seem like it's excluded, so I'm just wondering if that's...
Here in many ways it depends on what the focus is. So one of the things that you can do, of course, is you can describe the phenomena. And it's just a brute fact that Newtonian theory works really well for a lot of the phenomena. So if you're trying to gain modal understanding of the phenomena, you're interested in the representations that capture that phenomena and the relations among them. So as it turns out, you've got these general relativistic representations of the phenomena, those in the classical limit, and lo and behold, they're really, really close to these Newtonian representations. And learning about how those things relate is constitutive of modal understanding. So I would say, yes, that's definitely part of modal understanding. Now, one of the other things that you might try to do is, I suppose, rather than characterize your explorations in terms of, a phenomenal space of possibilities, you might just want to ask yourself about certain classes of theories and how their possibility spaces might overlap or not overlap.
This is why I said it was closer to Rob's question, right? So if you just think of a space of theories, how can you see those related to each other?
So, I'd say you see those related to one another in just the usual ways. Like, what are the boundaries of this theory's possibility space? What are the boundaries of the other ones? Do they intersect at all? If so, is it haphazard? Do all these things have something important in common? Is there, some deep reason about why they intersect, why they don't? I think all this is just great stuff. So I'm certainly hoping to accommodate those kinds of intuitions in this framework.
Time for one last question, perhaps?
Thanks, Steph. There's 2 hands up.
Well, I'm puzzled. I think I follow the debate about understanding and explanation, but it seems as though the way you presented things, finding out how the world is like, plays no role at all in understanding. It's all a matter of, knowing how and doing things with theories, connecting theories together, but even not having any notion of representational success or even truth in the way we represent the world. And it seems to me any theory of understanding which leaves truth out in principle, even if it's degrees of truth or degrees of approximate truth that is falsity, it's going to be inadequate. Precisely because it doesn't tell us how we manage to manipulate the world, how we manage to find out some things about the world which tell us what the world is like.
Yeah.
And I'm puzzled, because you spoke eloquently about these issues.
Sure.
But you avoided meticulously to mention the keyword.
I did. You're very perceptive. Look, part of the motivation for this view was to develop a notion of understanding that would be suitable for anti-realists. And the standard view of understanding as a product of a certain kind of explanation is very much connected to those realist notions. And I guess I really want to say that false theories can promote our understanding. And it seems like an impossibility if you introduce those kinds of requirements. Or if you're going to do it, then you're going to have to play the kind of game that's been so hard to play, say what aspects of theories are actually getting things right and what they aren't. And as you've done, as you've thought very carefully through several examples, you know that's hard to do. And you also know that these reconstructions have been contested as well. So the idea is to formulate a very neutral framework, but I see no reason why a realist can't add an additional demand to the framework and take that. And that's just fine with me. I prefer myself to have the more embracing notion.
Can I say something more?
Of course.
I mean, of course, you can always add something. The issue that puzzles me is when you can have knowing how without getting some knowledge done.
Oh, you've got tons of knowing that, but
but knowing that, which doesn't tell you just how to do things, but in virtue of what kinds of knowledge about the domain you try to represent, you manage to succeed in doing things.
yeah. So I'm not trying to explain the success of science or anything like that. You know, as you know, I'm avoiding this, right? So what kind of knowledge do you have? Well, I mean, one of the things you know is whether your representations meet certain kinds of adequacy conditions. Maybe. If you go realist in that sense, then there's, of course, these epistemological worries about whether you're meeting those adequacy conditions. But I mean, if we just stick at the phenomenal level, there's a question like, does this theory adequately represent the phenomena or not? And I mean, yes might be the answer, no might be the answer. This is simple propositional knowledge. So you need to know tons of simple propositional knowledge in order to have know-how, and I never wanted to suggest otherwise. So.
I just wanted to add a lost joke about understanding in quantum mechanics. That is, if you take a position, as soon as you take a position in quantum mechanics that you feel you understand, you begin to lose your momentum.